4.2 is about the mean value theorem. We're going to begin though with Rolle's theorem. Let f be a function that satisfies the three hypotheses. First, f is continuous on the closed interval from a to b, and second, f is differentiable on the open interval a to b. Number 3 would be f of a equals f of b. So Rolle's theorem states that there exists a number c in the open interval ab such that f prime of c equals 0. Or in other words, the slope of the tangent line would equal 0. We have some diagrams here. Here is f of a and here is f of b, and they're at the same height. So we know f of a equals f of b, and there are two values, c sub 1 and c sub 2, on that open interval such that the slope of the tangent line would be 0. Here in the second drawing is another example where f of a equals f of b, and we have slope of the tangent line would be 0. The third picture, here is the secant line connecting f of a and f of b, and in the last picture, here is the secant line connecting f of a and f of b, and it's horizontal, in all of these pictures. One thing that we can see already is that the secant line is parallel to that tangent line where we've located c. Let's apply Rolle's theorem. So we have a function f on the closed interval -5 to 4. We're going to check the hypotheses of Rolle's theorem first. F is a polynomial, so it is continuous on the closed interval, and it is differentiable on the open interval. Also, we will evaluate f of -5. F of -5 is -75. Now let's check f of 4. F of 4 is also -75. So we have satisfied all the hypotheses of Rolle's theorem. So we are allowed to apply Rolle's theorem. Since Rolle's theorem tells us there exists a c in open intervals such that f prime of c equals 0, we want to find f prime. So let's find the derivative of f, and then we're going to set that equal to 0. We find values of x equals 4 and x equals -2. That would give us a derivative equal to 0. But c must be in the open interval -5 to 4, and the only value listed here in that interval is -2. When you write your explanation, be sure to cover the hypotheses and then state the name of the theorem and what it is allowing us to do. So you state that you're applying Rolle's theorem and that you're allowed to say f prime of c equals 0. That allowed me to take the derivative and then set it equal to 0. Also make sure you include your conclusion at the end. The mean value theorem states that if a function is continuous on the closed interval and differentiable on the open interval, then there is a number c in the open interval such that f prime of c equals the slope. The mean value theorem is an existence theorem. It tells us that such a number c exists. Rolle's theorem is actually a special case of the MVT, and that is when f of b and f of a are equal. Let's look at the situation when f of b is not equal to f of a. So in the drawing below, pretend that this is A and this is B. So we have our interval, and that means that f of A is here and f of B is here. So obviously f of A and f of B would not be equal. They're at different heights. What the mean value theorem is telling us is there's at least one point on the graph of f where the slope of the tangent line is the same as the slope of this secant line. So you can imagine if I go over to the curve and I draw a tangent line that is parallel to the secant line, they would have the same slope. These two lines would have the same slope. So they're saying that this point P is on F at the location C. So this point is P with coordinates C, comma, F of C. And we know that if we take the derivative of F at C, we would get that slope. To get the slope of the secant line, we would take the change in y, which is f of b minus f of a, and divide by b minus a. So that would give us the slope of the secant line. F prime of c would give us the slope of the tangent line. So those two are equal. The example below, first let's verify that the function satisfies the hypotheses of the mean value theorem. The function is a polynomial. So we're going to start with f is a polynomial and is continuous on the closed interval and differentiable on the open interval. Therefore, the mean value theorem states that there exists a number c in open interval 2, 5 such that f prime of c equals f of 5 minus f of 2 over 5 minus 2. So let's find the derivative of f, and then let's find the value of this slope, and we'll set them equal to each other. The value of this slope is 107. So I'm going to let the derivative be equal to 107 and solve for x. The two answers are about 3.6 and negative 2.3. Only one of these answers is in the interval 2 to 5. That would be 3.629.